Alrighty, so our next tough integral is going to be the integral of secant squared x over tan cubed x minus tan squared x dx. And our first step is going to be to use u substitution. Now, I'm going to let u equal tan x because we'll see how our derivative of tan x is equal to secant squared x dx, which fits in perfectly with our dx over here. Our entire numerator actually right here. So what we're going to do next is we're going to replace all of our tan x's with u's, and well, to help you see more clearly how it is that we can convert our secant squared x dx into du, what I've done here is I've just moved the secant squared x outside of this fraction so that I have 1 over tangent cubed x minus tan squared x, and all of that times secant squared x dx. And now you can see how we can clearly replace all of our u's and du's. What we're going to do next is we're going to go ahead and simplify the denominator by pulling out a u squared, and what we're left with is the integral of 1 over u squared times u minus 1, and it is at this point that we know that we're going to have to use partial fraction integration, and we also have to keep in mind that we have a repeated linear factor, which is u squared. So we'll go ahead and set up our partial fraction integration, and what we have is the integral of a over u plus b over u squared plus c over u minus 1 du. And our next step, of course, is to sort of move away from the calculus and try to figure out what these values for a, b, and c are going to be. So I start with the original statement that 1 over u squared times u minus 1 over here is equal to this expression that we have here. And of course, I'm going to multiply both sides of this statement, this equation, by the denominator of our original function, 1 over u squared over times u minus 1. So when I multiply both sides by the denominator here, these get cancelled out, and this entire term right here gets distributed to each of these individually. And what we're left with is 1 is equal to a times u minus 1 plus b times u minus 1 plus c times u squared. And now it just becomes a matter of solving for a, b, and c. And in order to do that, we have to set values for u such that we can solve a, b, and c individually. And our first step is to let u equal 0, and that means plugging in 0 everywhere we see a u here. And what we're left with is that 1 is equal to negative b, or in other words, b is equal to negative 1. So now we just have to solve for c and a. To solve for c, we're going to let u equal 1, and we'll plug in our value of 1 everywhere we see u in our original equation, and we're left with c is equal to 1. And now for the third value, it's a little bit, I mean, you can really use whatever values you want. I decided to use negative 1 because I haven't used it yet, and because it's a relatively simple value to work with. But you'll notice that we actually do not cancel any of the terms by plugging in negative 1 everywhere we see the u. Instead, we're going to make use of the fact that we've already solved for the values of b and c, and therefore we'll be left with a as our only variable here, and we can easily solve and find that our value of a is equal to negative 1. So now that we have the values for a, b, and c, we'll go back to our original function right here with the u's, and we're going to plug in our calculated values for a, b, and c everywhere we see a, b, and c in this integral. And what that looks like is this over here, the integral of negative 1 over u plus negative 1 over u squared plus 1 over u minus 1 du. It's at this point that we can actually separate these integrals into 3 separate integrals, and we're going to make use of the fact that 1 over any variable x, when you're taking the integral of that, you simply have to, the answer is simply the ln of the absolute value of whatever's in the denominator. In the case of u squared, that's not the case, because u squared is the same thing as saying the integral of u to the negative second power du. And if we use the power rule of integration, we know that this is going to be 1 over negative 2 plus 1 times u up to the negative 2 plus 1, or, sorry, you couldn't see that. Or in other words, what we're going to have here is negative u up to the negative first power. And I've written that out over here, and I've done most of the long work so that we wouldn't have to spend so much time in this video, but our final answer should look something like negative ln times the absolute value of u minus 1 over negative u, which we got from here again, plus the ln of the absolute value of u minus 1 plus c. And it's at this point that we have to remember that our original integral was given in terms of x. So we have to keep our final answer in terms of x, which means plugging tan x back in everywhere for every term that we see u in. So we'll go ahead and plug tan x here, and tan x here, and we're left with negative ln times the negative ln of the absolute value of tan x plus 1 over tan x, which also happens to be cotan x, plus ln of the absolute value of tan x minus 1 plus c. We'll go ahead and simplify this and rearrange the equation so that we get cotangent x, which we got from here, plus the ln of the absolute value of tan x minus 1, which we got from here, minus the ln of the tan x of the absolute value of tan x, which we got from here, plus c. And if we remember the rules of ln's, you will remember that we can combine these two ln functions so that we get cotan x plus the ln of the absolute value of tan x minus 1, which is our positive term. And because it's being subtracted by tan x, the tan x actually remains in the bottom. Now both of these terms were kept in the absolute value, so I went ahead and I just put the absolute value and I had it correspond to everything that was inside of the ln function, and we can't forget our constant c. We can further simplify this function so that we get cotangent x plus the ln of the absolute value of tan x over tan x minus 1 over tan x plus c, and we did that by splitting apart this fraction here into tan x over tan x minus 1 over tan x, as you can see here. Our final answer after simplification is going to be equal to cotangent x plus the ln of the absolute value of 1, which we got from this function here, minus 1 over tan x, which is cotan x, plus c.